Hello friends, my name is Rahul Bajaj and today we're going to talk about infrastructure, securing your infrastructure with Keycloak. Now, a little bit about me. I'm a software engineer and I work at Red Hat. I have done few certifications related to DevOps and Linux administration. So if you want to ask me anything about it, then feel free to. And you can follow me on Twitter, GitHub, and you can also read my blog. So that's about me. Today we have a lot of things to cover, so I'll just go like a bit fast. But you can stop me anywhere and just ask me questions and just shoot. So the few things that we're going to look at today, one of them is authentication. Next is JSON Web Tokens or JWTs. Then we will go on looking at OAuth 2.0, what is OpenID Connect, and what is OAuth 2.0 workflows. After that, we will look at how we can use Keycloak as an OpenID provider and also how we implemented the single sign-on for Foreman project. So let's begin. So let's look at authentication. So what is authentication? Authentication by definition is the process used by applications to determine and confirm identities of users. Okay. So what this basically means that it ensures that the correct content is shown to the users. More importantly, it ensures that correct content is secured and unavailable for unauthorized users, right? So if there is an unauthorized user, we need to keep our information or our application away from them. That's the whole idea of why we need authentication. Next up, let's look at authentication. So I have divided authentication in basically two parts. One is the password authentication and the other one is the token based authentication. Usually what we have seen now, or what is in practice in most of the applications right now, is the password authentication, wherein a user goes to a particular website and he tries to enter his username and password. Once he gets authenticated, the server replies back with a session ID, and that session ID is stored in the cookies. And for every other request, cookies are used for trying to get some resource from the application. This is the general flow that we see. With this flow, we've also seen things happening like people using sticky sessions, load balancers, and also like people use something called as Redis cache to kind of try to scale. But what I've seen with this kind of method is that it is not very scalable. If you want to scale your application, then you might want to consider authentication via the token based authentication method. Now, what is token based authentication method? In this method, what you do basically is that you take a payload, and with that payload with that payload you kind of use that payload in your application to authenticate a user or get the user inside and then use the data in the payload and let the user access the resources that he wants. So when we talk about token based authentication, there's a very famous a very famous spec that is structured and which is called as JWT or JSON Web Token. So let us understand what exactly is JWT. So JWT, as you can see, it's a base64 encoded string, and by looking at it I cannot understand anything, but when I dig deeper into it I can see that it has three parts. So the first part that you can see in pink is known as the header. The second part that you can see in the blue is called as the payload. And the third part that you can see is the signature. Let's see what is the importance of all these three parts, and let's understand the JW token. So till now we know that it is a base64 encoded like string, but let's see now. The first part is called as I've already told you, it's called as the header. And what this header is basically, it is JSON that contains normally two fields. One is ALG and TYP. So in JWT, whatever keys you have, it is a key pair value, and whatever keys that you can see are usually three-letter words. And like the short forms, I don't know why they have done that, but it's ALG stands for algorithm and TYP stands for the type. So yeah, so this type here is JWT, but what you will see in the upcoming spec, like this is the spec. I know this font is kind of boring, and when you deal with authentication, obviously you have to deal with this font too. So yeah, so that's what you get when you want to try out things in authentication. It's the weird font. So yeah, we were talking about OAuth access token JWT profile. This is a future draft spec that they have created. Now, what they want in the future is called something called as the typed JWT. Now, what this typed JWT means is that inside the header parameter, we use something for the type something like 80 plus JWT. Now, why this is done? Because imagine you are you're using a huge application and you're developing a huge application, and that application uses JWT at multiple levels. So say for example you use JWT for say authentication, authorization, for say logout. So you're using JWT at different levels of your application. So how would you differentiate between all these kind of JWTs? Because all they have right now in their header is something like type is JWT. They all have it similar. So to avoid this, the proposed is type JWT. The ahead proposed way of doing it ahead is using a type as 80 plus JWT. That's the proposed way. So yeah, that's something new, and let's move on. So that's the first part. That's the first part of JWT, which is called as the header, which contains the algorithm and the type. Let's move ahead. There is this payload data, which is the most important part of a JWT, because that's what it contains basically. That's what it is made up of. Now, the payload type of data can be actually of multiple types, but the basic one is the one which is provided by the spec, which is all these like JTI, EXP, AIT, ISS, AUD, audience, issuer, expiry, and subject and type and things like that. Now, except those, you can have your own own keys over here. Now, this JWT, as you know, is provided by the OpenID provider. Now, I'll come to that in a minute, like what is OpenID provider and how they provide this JWT. But for now, just understand that this JWT is given to us by the OpenID provider or the authorization server. So we can add these, the fields that are new, we can add this through those OpenID providers or authorization servers. But if you look at a basic JWT, it would have only these 3-letter words keys. So that's about the payload data. And the last one is signature. Now you must be wondering, like you must be wondering, like, Rahul, wait, this JWT you told it's a base 64 encrypted string. So why can't an attacker just decode it and get all the information out of it? The attacker does not have the appropriate information to decode this because of this signature. Now let's understand what is this signature. What this signature is made of. The signature is made of the header, the payload, and a secret. So there is a payload. We saw what a header is. We take that header. We saw what a payload is. We take that payload. And there is a secret that the authorization server or OpenID provider, or in our case say Keycloak, it provides that secret key for us. We take all these things together, all three of these things together, and we again encode it with an algorithm of our choice. So signature could be of, say for example, in your header you have something. Let's go back and see what the header has. So say your header is of RS-256, but it is not mandatory that you use RS-256 for encoding the signature. So you have this as a base 64 URL, you have payload as a base 64 URL, and then you have a secret. And you take all these together and you basically encode this with another algorithm, or basically the same algorithm, whatever is your choice. You need to encode that, and that becomes your signature. And this is why this entire JWT that is passed from an authorization server or OpenID Connect provider is kind of secure. So I hope you've got the gist about JSON Web Token altogether, and let's move ahead. So let's recap what we have learned till now. So the first thing that we learned today is why we need authentication. What is authentication? Just to avoid the unauthorized users, or to access our application. So we use authentication for avoiding the unauthorized users to access our application. And then we learned about JWT. JWT is JSON Web Token. It has 3 parts: header, payload, and signature. It's very secure because of its signature, and that's why we can trust it. Now we're going to look at what is OAuth 2.0. So O here stands for open. Okay. But what is this auth all about? What does this auth stand for? Does it stand for authentication or does it stand for authorization? Now you might be, Rahul, that's crazy, because like we're here to talk about authentication, so obviously it's authentication. So no, that's not the case. It's for authorization. So in OAuth, OAuth stands for open authorization. It's authorization, guys. It's not authentication. Now let's understand what is OAuth 2.0, why we need it in the first place. So if you have ever, so let's take it this way. If you have ever logged into an application using your Google or say your Facebook account, that means you have used OAuth 2.0. Okay, so let me explain it in this way. When an application requires to authorize another application to use the resource, that is when OAuth 2.0 comes into the picture. Which also means that let's understand this with another analogy. That is, say for example, your parents come to your office just to visit, just a normal visit. The people, the staff of your office, or what we call it as is GWS of the office, will assign a particular card to your parents. Now this card will have access only to the common areas and restricting them from the workplace, the actual workplace where you sit and work. So the 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 goal of saying this is that they get a restricted access. So OAuth is the same way. OAuth gives a restricted access to the application who wants the authorization to access a particular resource. So that's about OAuth. Now let's see how it generally works. Let's understand this in a way that there is a resource owner or the user. I just like to call it the resource owner. There is a resource server, and there is a client, and there is an authorization server. Usually what happens is that this client makes a request to the resource server, but what happens is that he has to first go to the authorization server and he has to authenticate himself. So say for example you are trying to access some kind of website, and that website gives you an option to go to say authenticate yourself from Google or Facebook. So what you do is, here your authorization server, you go to your authorization server, you authenticate yourself. In return, it returns gives you back an access token, and this access token is then used to get the resource from the resource server. Okay, let's move ahead. OpenID Connect. Now, in case of OpenID Connect, you must know that OpenID Connect is just a very slim, like small layer above OAuth. So the best part is it is based on OAuth. So OpenID Connect is internet standard for single sign-on, and it is based on OAuth 2.0. So in case of OpenID Connect, when you want to access a particular application, you basically are redirected to OpenID provider. Of the OpenID provider, at the OpenID provider you authenticate yourself. It returns you an ID token instead of an access token. Here, if you see, I've changed the words. I get back an ID token, and with this ID token, I go to my resource owner and get the resources. Now, I have used two terms here. One is access token, which is when I used OAuth 2.0, and I've used something called ID token when I'm talking about OpenID Connect. So let me talk about both of these in a minute, but let's just see what OpenID Connect in general is right now. So it is an internet standard for single sign-on. If you want to authenticate using OpenID Connect, what you do is you need to send a user. You need to authenticate a user. Send the user to the OpenID provider. The OpenID provider, you need to authenticate yourself. Once you're authenticated, it'll give back an ID token back. Okay, there is a mistake in my presentation. I accept it, and I'm really sorry for that. It is get an access token back. Okay, so get an ID token back. So what's the difference between the two? When you do an authorization request to the authorization server, and the authorization server returns you an access token with which you can basically end up accessing a particular kind of resource, it's called as an access token. Whereas and that is the case of OpenID Connect. That is the case of OAuth. Sorry, I'm so sorry. I'm confusing you guys, I guess. So that is the case of OAuth, where you get an access token back. But in case of OpenID Connect, when you go to an OpenID provider and make a request, it returns you an ID token. Now this ID token contains the authentication status plus the payload, the information that you can go with to an resource owner, and you can get the resources that you want from it. Is that clear? So access token is when you get a token from the authorization server, and it's only for accessing a particular resource. Whereas IE token is when you get this IE token from an OpenID provider, and then which has the authentication status, and also the payload, the data that you require to access a resource in your application. I hope it is clear. So yeah, let's look at the OAuth 2.0 workflows now. So there are two workflows basically. One is the password grant workflow, and the second one is authorization code grant flow. Now the password grant flow is a little messy, and I would say it's soon going to be deprecated also. And what you need to do in the password grant flow is quite similar to what we do in the password authentication, where you actually provide your credentials. Whereas the authorization code grant flow is the one which is quite popular, and it is very much used in the industry. So let's look at how they work. Okay, so talking about this password grant flow. So again, there is a resource owner, and there is an authorization server, and there is an client application. So what you do is that whenever you request your client application, it basically redirects you to the authorization server. Now at the authorization server, you give your credentials, you get back an access token, and that's how you can access the client application. That's the basic flow for password grant flow. But things change quite a bit at the authorization code flow. Now this is quite interesting. I will explain you like in a very slow pace so that you understand everything. So say for example you have your client application, you have a client application, and then you make a request to a particular website or application. Now what will happen is your browser will be redirected to a authorization server. Okay, or you can say OpenID Connect provider. Now what this OpenID Connect provider or authorization server will do is it'll ask you for your credentials, or it'll ask you for the authentication type. Now this type could be a different type, like it could be a Google OTP, it could be smart card authentication, it could be anything, any kind of, it could be a two-factor authentication is what I'm trying to say. So what you do is you're redirected to this authorization server, and here you enter your credentials. If your credentials are correct and if you're authenticated, you will the authorization server will return back something called as a code. Now a code is basically a string of letters. Now this string, which is called as code, is returned back to your application and given back to your browser. Now your browser will again make a request directly to the authorization server with this code, and the code will verify, and the authorization server will verify if this code is accurate or not. If it is accurate, it will give back an access token, and this access token will be used by your browser or client to access the application that you were originally trying to. I hope this is clear. Let's just summarize. Your browser makes a request to the application, or your client makes a request to your application. Your application goes to the authorization server. It does the authentication. It gets a code back. This code is again used by your client, and then your client will send this code to the authorization server. In return, it will get back an access token, and this access token will be used to access your application that you were initially trying to. I hope this is clear. Let's move ahead. So these were basically two flows that we discussed. One about password grant flow, and the second one was code grant flow. Now the next topic, the next important topic that we're going to talk about is Keycloak. How it is used as an OpenID provider. I will show you how the console looks, what all things you can do with Keycloak, and yeah, that's pretty much it. Let's see how Keycloak works. So I already have a Keycloak instance that I have been using for my development purposes. So when you go on the Keycloak website, this is something that you see. Let me show you the administration console, and let's log in. So here we are. This is how Keycloak looks when even when you enter it for the first time. You can create your own realm. Let's create a realm, calling it stackconf demo. Okay, so you have something called as realm settings, and then you have something called as clients. So usually what you do is whichever application you want to integrate Keycloak with, you basically have it integrate. You basically register it as a client inside Keycloak. And the good part about Keycloak is that you have multiple identity providers here, wherein you can use Google, Twitter, like multiple social media platforms. Other than that, you can also use like user-defined providers such as SAML 2.0, OpenID Connect, and Keycloak OpenID Connect, and multiple social media identity providers. Other than that, if you are a huge organization and you use something like LDAP or Kerberos, you also have those options. So it's pretty flexible, right? And then you can also define your bindings so that if you if you have the smart card authentication, wherein you have the certificate kind of authentication, or you're using uh, any other type of authentication like OTP or something like that, you can change it from here. You uh, when you have those particular packages installed on the server, you will be able to see those options here in the binding. So that's about it. You can add users here, you can assign users to those particular groups, and you can manage sessions from here. Also, what you can do is that let me show you one of the like realms that I'm working on, so that it gives you a better understanding. So yeah, this is how a client looks, wherein you can choose the client protocol, wherein you can choose the access type, which we will talk about in more detail in a few minutes. And this is the client ID, and you have valid redirect URLs. If you see here, you have something called as advanced settings, and this is the wherein you can set the access token lifespan. So quite a lot of features that you require for implementing OAuth are all present in Keycloak, so it's quite cool. Okay, let's move back to our presentation. Okay, so the next step is registering different clients. So yeah, so now I'm going to share some things with you that I particularly faced when I spoke to people who are kind of trying to implement this algorithm, or this kind of flow, the code grunt flow, into their applications. So one thing I noticed is that if if people have an application which has CLI and a UI to their application, so they have just one type of access. They use just one type of access type. If you see here, like when I showed you uh, the Keycloak console, you have something called as access type over here, right? Which has options like confidential, public, and bearer only. So mostly these two options are used, like confidential or public, and it is very important for you to identify which type of client it is. So let's look at the presentation. This I have taken up from the um, Keycloak documentation, which says public access type is for client-side applications that need to perform a browser login. With a client-side application, there is no way to keep a secret safe. Instead, it is very important to restrict access by configuring correct redirect URLs for the client. Redirect URLs for the client. Okay. So, sorry, redirect URIs for the client. So, what this means is that if you have a server-side application, so I will show that to you in the demo, that you will see that Hammer CLI is a client, is a CLI client, and whereas Foreman is the server application that we're going to use for the demonstration. So you will understand that they are different types of clients, and for different kind of clients you must have different kind of access types. Now what I've seen in the applications that mostly I have seen is that they just have confidential clients. In confidential clients you have something called as secrets, and these secrets are used to these are like symmetric keys which you share on your client and your on your authorization server, like on your OpenID Connect provider, like Keycloak. So if you see, we have in the credentials section, we have this something called as a secret. So this is what I was talking about. So this secret is used on the client side, and this is also stored on the server. So this is basically a symmetric kind of a secret, and whenever the client does a request to the server, client does a request to the server, it basically does it with this secret. So the server tries to check if this secret is correct, and then it does the authentication. But that is not the case in the case of in the case of public clients. So when you have a public client, you don't use secrets, because on the public clients you don't have a way to keep your secrets safe from getting leaked. So we don't use secrets in public clients, so you must take care of this. I have noticed that a lot of applications don't do that, and so you should keep different clients, register different clients. In fact, in the spec for OAuth 2.0, it particularly says that you must not be shy of using different registering different clients. So yeah, so this is one thing that I wanted to mention. The another thing is that redirect URL. So redirect URLs are supposed to be very specific, and to your it must be your application server side. It must not be something like a third party you're redirecting to. It should not be like that. It should be your own code, server side code that you have written, and you have basically control over it. And it should not be something like this. I've seen in a lot of cases where people do something like this, like they put their domain and then they put a slash and then they put a star. So this is not correct, and this gives more scope for the attackers to make your application vulnerable. In the same way, you must not do something like https:// and then give a star.example.com, because this is, again, it gives a lot of space for the attackers to get through your website. You must take care of redirect URLs. If you have forgotten already, let me show you where these redirect URLs can be found. You can go to your client. Inside your client, you will have these redirect URLs. It must be very, very, very specific to your application, and you must know like where you're redirecting to. So that's about it. And let's look at the next thing, session management. Oh, sorry, I forgot to tell you something here. So when you're using public clients, you give a lot of space for attackers to attack your applications. Even if you're using code grant flow, right? When you're using code grant flow, what happens is that after a certain point, this happened to me with my application right now. So after a certain point, my SSL terminated at the load balancer, and after that, it was just plain text. So the code could be the code that is passed in the OAuth grant flow method. If you remember code grant flow, there's a code that gets passed. That can be retrieved by an attacker. Now, once the attacker has the code, it can basically get into the system and do stuff. So what they did is, what the folks in the community did is, they they removed something called as proof key for code exchange. So let me show that to you. Proof key for code exchange. Yeah, this is the RFC, and what it says is that PKC is an extension of authorization code flow to prevent certain attacks, to be able to secure perform OAuth exchange from public clients. It is primarily used by mobile and JavaScript apps, but the technique can be applied to clients, any clients as well. So it is a good practice to always have PKC implemented, whether you have a public or a credential or a confidential client. But it is always it is always said to be a good practice to have this in place. Most cases, when you're using a public client, it is a must, so you must have it. Okay, so I haven't implemented it in my application, but yes, I have to in few days. So yeah, so you should have this in your applications if you were using a public client. So that's about it. Let's get back and let's move to the next slide. Session management. Now you must be thinking, Rahul, what is this? Why is this slide empty? This slide is empty because it has to be empty. the spec does not provide a very specific way of how to manage a session. It does not say what is the appropriate time, what is the exact appropriate time to log out. It does not give us the exact appropriate time for the access token. It does not say how you should log out. So for example, you are on, so let's consider this use case, okay, wherein you are logged in from your browser and you are also logged in from your mobile application or like any other mobile application. So once you log out from your mobile, should you be logged out from your browser also? No, right? You would be very frustrated with that. So these kind of things, right? The session management in the spec, it does not mention anything about how you should, log out, or how much time your access or your ID token must be valid and things like that. So this is, kept blank intentionally. But there are some mechanisms that the spec does provide. That is, one of them is the refresh tokens. Let's understand this refresh token. So there are access tokens and there are refresh tokens. So when you do a request to the auth server on the first time, that time it gives back to you an access token and a refresh token on the first time when you do. Now in this diagram, you are already authenticated. So now you already have an access token and a refresh token. Consider that. Now what happens is that when your access token expires on the client side, when say your access token has expired on the client side, what this client will do, it will send a refresh token to this auth server. Now this refresh token will this auth server will use this refresh token to generate another access token, and this access token will be passed to the client again, right? And then this access token, the new access token, is used for authentication, and then you can have access to the protected resource. So this is how it works. So every time you make a request, every time the client makes a request, it gets an access token and a refresh token, a pair of them. And what happens is that whenever the access token is basically supposed to be for short-lived, and refresh token is supposed to be long-lived. So whenever your access token expires, the client sends the refresh token, and the auth server sees if the refresh token is valid. It again returns access token. It also returns the refresh token. Not that the refresh token is now changed or something. It returns the pair of both access token and refresh token. So it returns them both, and the new access token is used to use the resource server. And when this access token again expires, the refresh token is used to get the pair of access token and refresh token. So that's how this method works. So that's about it. That's about how refresh tokens work. So we've come to the final and the third part of this presentation, that is implementing OpenID Connect with Foreman project. And let me give you a quick introduction about what is Foreman project first, and then we will move deep into how we have implemented SSO with the Foreman project. So let's understand what is Foreman first. Foreman is a complete lifecycle management tool, right? So when we talk about Foreman, we talk about complete lifecycle management. Okay, so when we talk about complete lifecycle management, we do provisioning. First you provision your machine, then you configure that machine, and then you do monitoring. So normally, whenever we see a lot of tools that do configuration management. So when can you do configuration management? Once you have a base operating system, upon that you can do configuration management. Once you have the configuration management done, you need to monitor those machines to see that if they are still maintaining that state or not. So these are kind of things that segregate all three components, but with Foreman you get them all together. So you can do provisioning, configuration management, and you can do monitoring. All of that as a complete lifecycle management you can do with Foreman. So let's see the demo now, and after that we will see the architecture. Let's see what all things that we have right now. So if you see, there is my terminal. If you see my terminal, I hope you're being able to see it clearly. There is this this server, Foreman server, that is running around, and there is this Hammer the Hammer CLI, which is the client application. And let me show you what we have over here. So let me open up Foreman for you. So since I, sometime back I had just logged in, so it didn't ask me for a username password, but that's how you kind of log in into Foreman. This is the dashboard for Foreman, and then you have like the hosts, and then you have discovered hosts. You can create your host. You can provision machines from basically from Foreman. You can configure those hosts. You can have host groups, discovery rules, and you can have different organizations, different locations, and you have tons of things to do here. You have infrastructure, like you can set up subnets, domains for where your host should be, created for, and then you have this administration and then toolbox. So what we're going to do here, look at here is the settings, and inside the settings, what we're going to do is go to the authentication and check this out. So we have this algorithm, OIDC algorithm, OIDC audience, the issuer, and we have the JWKS URL. So let's now see the slides and see if that makes sense. Let's see this. So Hammer CLI over here is a client application which has the which is going to make the request. So Hammer will first, what it'll do is it will request Keycloak for a token. So Hammer goes to Keycloak, it does its request. Now Keycloak performs authentication and issues a token to Hammer if the user is valid. If the user authenticates itself, then what will Keycloak do? It will return back a ID token. Now once Hammer CLI Foreman gets the token, it passes this token to Foreman. Now Foreman, this is very important. This part is the most important part here. Is that when Foreman receives this token, right? It could receive this token from anywhere. Like it could receive this token from API or anywhere, right? So we cannot trust the token that is coming from Hammer directly. We need to verify that token. Now to verify that token, if you remember, it's a JWT. The token is a JWT. Now in that JWT, there's header, there's payload, and there is signature, right? Now what we do is we decode this entire JWT and we check the fields. We check the fields of the token. So so we validate the token, and then if the token is like a authentic token, then we create a user in the Foreman database. After creating a user in the Foreman database, then we go back to our previous implementation of Foreman creates its own session ID, and then that session ID is passed to Hammer, and that Hammer uses now every time to talk to Foreman. So this is kind of the architecture that we have figured out in our particular way, but you can manage logout, or you could have use refresh tokens, or you could do stuff like that. But as I said, session management is up to you and your application architecture. So this is what we follow. Let's revise it again. So Foreman gives so Hammer CLI requests Keycloak to give it the token. It does authentication, then it gets the token. This token is passed to Foreman. Foreman basically validates this token. If it is an authentic user, then it creates a user inside Foreman database and also creates a session ID, and this ID is passed to Hammer CLI, which it stores in its local storage. So that's about it. And now let's look at what we have, which will make more sense. So we have a Foreman server running here, and we have a Hammer CLI machine here on which Hammer CLI is deployed. So here what I'm going to do is I'm going to run a command here. So it says Hammer auth login OAuth 2-factor. So this is 2-factor authentication. That is why it is called 2-factor. And then there is OIDC authorization endpoint. So you require this authorization endpoint, which let me explain you this in another way. So let's get back here. Okay, so there is this URL called well-known URL. So if you go to this well-known URL, you will get all the endpoints. So making a request, you need the authorization endpoint, you need the token endpoint, and then you need other parameters like the client ID, and then you need the redirect URL. So all these things, like you need all these parameters, and that's how you can log in. So and one more thing, like the most important thing out of it, I was explaining you that, and then I lost track, so I'm going to explain it to you now. So in Foreman, if you see, like we have four parameters: the audience, the issuer, the JWKS URL. So all these parameters are also found at this endpoint URL, like this well-known OpenID configuration. So you get all these endpoints there. And what you're doing is basically when Hammer will pass the token to Foreman, Foreman needs to validate that token. So how does it validate? So inside the header, if you remember, you have the algorithm mentioned. So we check if the algorithm mentioned in the header of the JWT matches with the header that with the algorithm that we have provided here. Then we check the audience. Odd AUD was a parameter in the payload, so we check the so what we're doing here is we're checking the header. If the values of the header are authentic, we're checking some claims. They're called claims, right? This audience is called claim, issuer is called a claim. So we are basically checking these claims. So we check the header here. In this, we check the payload. This is again from the payload, so we check the payload again. And this one is to check the signature. So OIDC JWKS URL is basically where it contains its certs. So we check if this, if we basically encode the signature, and then we check if the signature gets, if with providing this JWKS URL, if the signature, if the entire JWT gets decoded and the signature gets verified. So this is what this parameter means. So we have all these endpoints over here. So JWKS URI is here, and authentication endpoint, token endpoint, you get all these parameters here. So going back to the demo, let's see how this thing actually works. So what we'll do is we will run this command and we will see what happens. When you run this command on the back end, what is happening is now Hammer is going to Keycloak and trying to request something. But what you need to do is you get this URL. It says enter URL in the browser. So what we do is we copy this. So according to the parameters that were passed over here, just ignore these warnings. Those are not important. So with the parameters here, we have created a URL and we are saying that enter this URL in the browser. So what we're going to do is we're going to copy this URL and we are going to just maybe open an incognito mode and then just paste this URL. Once you paste this URL, what happens is you are redirected to Keycloak. Now, once you are redirected to Keycloak, you need to perform your authentication here. Now, this page of authentication could be anything. Right now, it is say it's asking me for username password. It could be like Google Authenticator. It could be like OTP. It could be a smart card where you insert a smart card and then you get authenticated. So it could be any kind of authentication, right? And you need to choose that from the bindings that I showed you in like the previous demo about Keycloak. So that's about it. So I'm just going to log in. I just created this dummy user called XYZ. So I'm just going to log in. And you see it returns me the code. It returns me the code. I'm going to copy this code and go back to my Hammer screen. And I'm going to paste the code here. Now, what Hammer will do, it will take this code, it will go back to Keycloak and get an access token. Once it gets the access token, it will go to Foreman and then check if everything is correct. If everything is correct, Foreman will create a session ID and return it back. So if you see here, it logged in as the user XYZ. Now there is one way that we can check this thing is there is a file called session file. If we do a ls here and then we cat this particular file, you will see that there is a username and it just got updated, like so yeah, so that's about it. And yep, that's basically what I want to say. So just revising what we have learned right now is that Hammer requests Keycloak for a token, but Keycloak, you need to go to Keycloak and then Keycloak returns you the token, and then you give that token to Foreman. Foreman validates it and then returns back a ID. That's about it. And let's just look at the code flow once again. So yeah, so what we did here is you try to access an application. That is, in our case, we tried to access Foreman. It gave us an URL to go to authorization code. Here, when we did the authentication, it gave back us the code string. We pasted that string in Hammer to give back to the authorization. Then it gave the authorization server. The authorization server in return gave us the access token. Once we got the access token, we sent it to Foreman to verify if it's authentic. If it was authentic, it returned the successful login. That's pretty much it. Now, there is one thing that I want to discuss in the end, which is again coming back to this slide, is that the only things that I want you to take away from this particular talk is that uh, these three things. First thing is that register different clients. If you have different types of client, identify them. If you have a confidential client, make it confidential. If you have a public client, make it public, and identify the type of identify their access types and then do it correctly. Second thing is don't do vague redirect URLs. Always have correct redirect URIs, okay, and don't use your stars and things like that. And think about your session management, how you want to do it. Do you want to have those access token, refresh token kind of things, or do you want to do it once you authenticate and then the ID token, you don't want to do anything with the ID token now and just use session IDs like you were doing earlier? So yeah, there are different ways you can do it. So just identify your way that suits you the best. I have specifically used a lot of references here, and I'm glad I could share it with you. Uh, but if you go through these specifications, right, they are quite boring. Like if you look at them, reading this is a little difficult. I feel it's a little difficult because it's kind of like this kind of font is boring to read and it's quite lengthy and it's all technical language, so it kind of bores you. So what I would suggest you is you could either go through these blogs and journals that I have went through. These are IEEE blogs and some things taken from the journal. So this is quite good. Both these articles are quite good. Other than that, I also like to watch YouTube videos. If you have seen the slides closely, I have taken some of these slides from Dominic. So thanks Dominic for just creating all these wonderful presentations and sharing it with us. So yeah, this video is really helpful and I got a lot of insight from here. I also recommend you watching this Authentication as a Microservice by Brian and A Reasonable Guide to Security by Neil. So go ahead and thank you so much for your time. I hope this was useful and take care of yourselves and all the best to you. Thank you.